Welcome to The Explainer, where we break down big ideas. Today, we are diving into a question that feels like it's straight out of science fiction, but it's actually at the very heart of cognitive science and AI. And that question is your brain a computer?
For centuries, people wondered about this. Could a machine actually think? Could our own minds be some kind of thinking machine? It was all just speculation, right? Stuff for philosophers to argue about. But then the computer revolution came along and everything changed. Suddenly, this wasn't just a thought experiment anymore. It was a real scientific question that researchers could actually get their hands on.
And out of that revolution came one really powerful answer: the computational theory of mind, or CTM. Now, get this. This theory isn't just saying the mind is like a computer. No, it's making a much bolder claim. It's saying the mind literally is a computational system. That's a pretty wild idea, so let's break it down. All right, so let's jump right in. To even begin to understand how your mind could be a computer, we first have to get really clear on what we even mean by computation. And to do that, we need to rewind a bit, back to the very foundations of computer science.
So at the very heart of computation is this thing called an algorithm. The best way to think about it is like a recipe. It's just a super explicit, step-by-step procedure for getting something done. And the key here is that it's all routine. It's all mechanical. You don't need any special genius or creative spark to follow the instructions. You just do them.
And speaking of mechanical procedures, in 1936, the absolute legend Alan Turing came up with this brilliant abstract model for a computing device. It's called the Turing machine. And what's so amazing is that this simple, imaginary device is powerful enough to handle any mechanical procedure a human could possibly follow. It's the blueprint for everything. And when I say simple, I really mean it. Just imagine a little scanner moving along a long strip of paper tape. That's the whole setup. And based on its rulebook, it can only do 4 things: write a symbol, erase a symbol, move one step right, or move one step left. That's it. It's almost ridiculously simple. But from those 4 tiny building blocks, believe it or not, all of modern computing emerges. Okay, so we have this purely abstract mathematical idea of a computer. How in the world did that get applied to the messy, emotional, complicated reality of the human mind? Well, that's where the next piece of the puzzle comes into play. Well, a philosopher named Jerry Fodor took an old idea and really ran with it. He proposed that our thinking happens in a kind of internal, private language. He even gave it a name: mentalese. The basic idea is that our thoughts aren't just fuzzy feelings. They're actually built from symbolic parts, kind of like how sentences are built from words. Now, this language of thought idea is super powerful because it seems to explain 2 really key features of how we think: systematicity and productivity. So think about this for a second. Why is it that if you can understand the thought, John loves Mary, you can also, without any extra effort, understand Mary loves John? It seems totally obvious, but actually explaining why that's possible is the real challenge.
The theory's answer is actually pretty simple and kind of beautiful. It says that if you have the mental symbols for Mary, loves, and John, you can just rearrange them in any systematic way. Your thought isn't just one big mushy feeling. Nope, it's made of distinct, reusable parts. Just like a computer manipulating symbols on its tape.
Okay, so this classical view of the mind as a kind of logic machine was pretty compelling. But it wasn't long before a major rival showed up. And this new challenger looked at the actual physical brain and asked a really simple but devastating question. Does the brain really work like that? This rival theory is called connectionism. And its inspiration wasn't abstract logic or some theoretical computer. Nope. It looked directly at the brain's physical structure, at neurophysiology. So instead of imagining a central processor and a memory tape, it pictured a massive, sprawling network of simple, interconnected nodes. Kind of like the neurons in our brain. So this really brings us to 2 completely different pictures of the mind. On one hand, you have the classical view. It's inspired by logic and computers. Its core idea is just rule-governed symbol crunching. Think of a central processor running a program. On the other hand, you have the connectionist view, inspired by the wet, messy reality of the brain. Here, the core idea isn't rules, it's waves of activation spreading through a network of interconnected nodes. I mean, you couldn't really imagine two more different ways of thinking about thought itself. So, you might be thinking this is all just some abstract philosophical debate for the ivory tower. But here's the thing, it's not. This debate has become incredibly practically relevant because it's shaping the artificial intelligence that we are all using every single day. And if you look at the timeline, the progress in AI has been just breathtaking. I mean, it started back in the 50s with programs that could prove mathematical theorems. Then in 97, Deep Blue beats the world chess champion, a huge deal. But then in 2016, AlphaGo defeats the world's best Go player, a game that's way more intuitive. And just a few years later, boom, we get these incredibly powerful language models. The pace is just staggering. So after all that, which of these two big ideas ended up winning out in the world of AI? Well, the answer is pretty clear. Today's most powerful AI systems, like ChatGPT, are built on what are called deep neural networks. And guess what? Those are a direct, supercharged descendant of that brain-inspired connectionist model. So let's pull this all together. The big idea is that the mind might be a computational system. From that, we get two really powerful competing models. You've got the classical computer view, where the mind manipulates a kind of language of thought, and then you have the rival model, the neural network, which is inspired by the brain's actual structure. And this debate, this tension between these two ideas, is exactly what continues to drive the incredible development of artificial intelligence. And that leaves us with one final kind of mind-bending thought. Whether our mind is a classical computer or a neural network, the core idea that it's a computational system is still on the table. And if that's true, it leads to the ultimate question. If the mind is just a computer, then what program are we running?